Infinite scroll is one of the most common patterns you see in modern apps and websites. For instance, on TikTok, as you scroll, the videos just keep loading. Same thing over on X. As you scroll in your feed, the posts just keep loading. You can just keep scrolling forever, as we sometimes do. And in this video, I'm going to show you how to implement this in React in a very easy way. So we have here a web page which loads images from an API. But then once we reach the bottom of the page, it automatically makes an API request and loads the next set of images, which makes it so that we can just keep on scrolling and scrolling and scrolling. So let's build this thing. My name is CJ. Welcome to Syntax. To get started, I generated a basic app with Vite, and I chose React and TypeScript. So you can run this command, give it a name, and then we'll choose React, TypeScript, and then go into the directory and install all of the dependencies. Once the app is generated, I removed everything extra. So our index.css is completely blank, and I have an app.tsx that just has hello world inside of it. So if I run an npm run dev, we can start it up, visit it in the browser, and it should just say hello world. Next up, I'll set some basic styles on the HTML element. So inside of here, I'm going to select the HTML element and set the background to be a midnight blue. And so that should give us a nice blue background. Next, let's create a loading element. So inside my app.tsx, I'm going to create a div and then give it a class of loading. And then to style it, I'm going to set the width and height to 50 pixels. And then I'll set the border color. So we're just going to do a 10 pixel solid border set to gray. And so I should have a nice little gray box on the screen. But I want to make this a loading spinner, so let's make it a circle. So I'll add a border radius of 50%. That should give us a nice circle. Then if I set the border top color, we'll get a nice little arc. So I'll say the border top color should just be white like that. And now we have a nice little arc on top of the circle, but now I want this thing to spin because it's a loading spinner. So I'm going to set up an animation. So I'm going to add a keyframes here that just is called spin. And all this is going to do is just rotate 360 degrees. So I'm just going to say 2, and we'll do a transform, rotate 360 degrees. And then on the loading element, I can set its animation to be to spin and then give it a duration. Let's say 1 second, give it an easing function and say we want it to spin forever with infinite. And just like that, we have a little loading spinner. Now let's style the parent element, which contains this loading spinner and is also going to contain all of the images. So I'm going to target that main element there, set it to a flexbox, set the flex direction to column, and then do a place items of center. So by default, that should just center that on the page. But because I want to have a single column of images, I'm going to set a max width here of 400 pixels and then a width of 100%. And so by default, it's going to shift it over to the left. But now I want to center that on the overall page. So I'm going to set margin. Let's do 1 rem auto. So it'll have 1 rem of margin around it, but it'll be centered on the page itself. If we look in the element inspector here, we can take a look at main and see that it actually has that margin on the edges that puts it into the center of the page. And so this is where we're going to load in all of our images. Now to load the images from the API, I'm going to use this hook called useAsyncList, and this actually comes from React Stately. Now React Stately is a library that is a part of React Spectrum, which is a library that comes from Adobe, and they're known for their very accessible component library. But we can install this library and only use this hook. We don't have to use their components. And specifically, they support infinite loading. It's actually super easy to set up. You can do useAsyncList. You have a function that can call your API and then return the list of elements and a cursor to the next page of elements. Now, you might have seen this implemented with something called tanstack query before, which is completely valid. But if you're not already using tanstack query in your application, it's quite a bit of setup just to get access to their use infinite query hook. So for one-off projects like this, where maybe you're doing like some autocomplete or infinite scroll like we're implementing here, this library is really great for that. So let's install it. I can do an npm install of React Stately. From there, I'm going to copy their infinite loading example, this useAsyncList function here, and then throw it at the top of my app. Then I need to pull in useAsyncList from React Stately. Go ahead and format this code with my linter so it's happy. And then we can actually see this in action. So by default, it's just going to reach out to the Pokey API and it's going to load the first page of results. So let's actually just console log our list.items. And then if we take a look in the DevTools, whenever the page loads, we should see those items that are loaded from the API. So for our API, we're going to be using Pexels. They're a stock photo website. They have an API, and I've actually just wrapped up their API calls into a serverless function so I can hide my API key. But if you want to call their API, you can get an API key there. And so my serverless function basically allows you to pass in a query, you get back the response, and then you can also pass in the page. So if we pass in page 2, we'll get the next page of images. So in the codes, instead of calling the Pokey API, I actually want to call my serverless function here, but I'm going to parameterize it just a little bit. So first of all, I'm going to pull that URL into a variable. So let's just call this the base API URL. I'll turn this into a template string. And then I'm just going to replace this query here with just nature. And our API also accepts a page parameter. By default, it's set to 1, but we can set it to 1 just like this. Now, I want to work with this API in a type-safe way. So one thing I can do is I can copy this JSON response here, and then I have an extension here in VS Code called paste JSON as types. So if I do Command-Shift-P, paste JSON as types, and we're going to choose TypeScript, and I'm just going to call this the image search response. That generates a nice little TypeScript interface here that describes the specific response that I'm getting back from the API. And now that I have those types, I can actually use them here. So when I do res.json, right now it's just the any type, but I want to set this as the image search response. And now I get some type errors because it knows what properties actually exist. And you can see on the type here that it actually has a photos property, and that is the items that I want to pass back here. So we'll just do json.photos. And let's not worry about cursor for now. Let's just get the images loading onto the page. Now, useAsyncList is a generic, and you can see right now it has unknown, but I can actually tell it that this is a list that contains photos in that items array, and we can actually use this type here that got generated for us. So if I say useAsyncList of photo, now we can see that this list actually contains photos inside of it. So now that we have this list of photo, let's actually iterate over it here in our JSX. So I'm just going to say list.items.map. And for each one, we're going to create a div. Now for the key, I'm going to use item.id. Our API actually responds with unique IDs for each. And then I'm going to give this a class name of item. We're going to set that up in the CSS. So if we hop over to our CSS, in here, we'll create an item class. And I want these images to be rounded, so I'm going to set the border radius on the container here to just be 2%, so we get some nice rounded corners. And then I'm going to set a background color here. So I'm just going to set background, and I want it to be gray, but I want it to be like transparent gray, so I'm going to use RGB to do that. So 127, 127, 127 is like a standard gray, but then I'm going to set an opacity of 0.2. I'll give it a width of 100%, so it takes up the full amount of its parent container. And then just so we can see these on the page, I'm going to give it a height of 400 pixels. And so just like that, we now see a div for every image that's going to load on the page, but I actually want some space between these. So in the parent container, because this is a flexbox, we can use the gap property, and I'm going to set the gap to 1 rem. So now we should get some nice spacing between each of these. And then lastly, to give it some depth, let's add a drop shadow. So on the item class here, I'm going to say filter drop shadow. And the X offset, I'm going to set to 1 rem, and then the Y offset is set to 1 rem. So this should be like a diagonal bottom right drop shadow. And then we can set the blur amount. I'm going to set this to 1.5 rem, and then I'll set the shadow color to black. And just like that, we get a nice little drop shadow kind of trending towards the bottom right of each of these little images. Now, when each of these gets added to the page, I actually want them to fade in. So let's add a fade in animation. So down here, I'm going to create a keyframes for fade in. And this is essentially just going to go from opacity 0 to opacity 1. So we'll say to opacity 1, and it's coming from opacity 0. And then on the item itself, I'll set the animation to fade in over, let's say, 2 seconds. And so now when those images get added to the page, they slowly fade in. Great. Now let's actually show those images. I'm going to get rid of this fixed height because we're going to be setting the height dynamically in the JavaScript based on the API response, because it actually includes width and height info. So let's remove the height from there. And then here on the image wrapper, I'm going to set some inline styles. So I'm going to set the style and set the aspect ratio. And I'm going to set this to item width divided by height. So our API actually has that information. So if I do item dot width, this is an actual number that our API responds with, and then I can divide that by item dot height. What's nice about this is because I set the width to 100%, now the height will automatically be calculated based on the actual aspect ratio of the original image. So I don't have to set a fixed height here. It'll be a dynamic height based on the width of the container because I set the aspect ratio here. So if I save this, we should see that some of our images are shorter, some of them are longer, but now they're the perfect size to actually receive the image itself. So inside the element, I'll create an actual image element. We'll set the source equal to item.source. You can see that the API responds with a bunch of these. I'm actually just going to choose the original one, and then we'll also set the alt text. And the API also responds with an alt attribute, so we can set that on the image. And just like that, it breaks. We need to set the image itself to be a width of 100% because right now it's flowing outside of that parent container. So let's do that. So here in the CSS, I'm going to target all images that are a child of the item class and set their width to be 100%. And that looks pretty good, but our border radius isn't actually showing up. So on the parent container, I'm going to set overflow to hidden. And then this way we actually see that border radius instead of the sharp edges of the image. So pretty good. We've got a nice little set of images here, but now we're on to the important part, which is when we reach the bottom of the page, we need to actually request the next set of images. And for this, we're going to use intersection observer. So this is a JavaScript API that will allow us to detect when a specific element is visible in the viewport. And so essentially what we want to do is when this loading spinner is visible, we want to make the request for the next page of images. Now we could use the intersection observer directly, but it's a little bit tricky because we have to deal with refs and we're inside of React. So there's this really great library. It's called React Intersection Observer that gives us a hook called useInView. And then it makes it super simple to watch a specific element to see when it's in the viewport. So to use this, I'll install it. And then we can copy their example here. And right below our useAsyncList, I'm going to say useInView. We're going to bring that in from React Intersection Observer, and then we'll pass in some options in just a second. And so really all I need to know is the element in view? And they give us this ref here, which we can pass to a specific element, and it'll tell us when that element is in view. And the element that I care about is this loading element here. So I'm just going to pass in the ref. I'll say ref equals ref. And now it's actually going to watch that to see when it's visible. So let's actually create a use effect here. And the thing that we're going to be dependent on is in view. And so whenever in view changes, this use effect will run. And for now, inside of here, I'm just going to log is the element in view. Now, before we watch this for changes, I'm actually just going to remove the console log of the items so our logs aren't cluttered up. And if we go back to the browser and refresh, we'll see that when the page loaded, it was not in view, and then it was in view, and then it's no longer in view. So because there were no images, it was visible, but then all of those images pushed it down, so it's no longer visible. And then if I scroll all the way to the bottom of the page, we can see that it is now in view. And so essentially, whenever this gets set to true, we now want to make a request for the next page of images. Now, this is where that cursor property comes into play, because when the page loads, we want page 1. That makes sense. But when a user reaches the bottom of the page, we want to request the next page of images. So the cursor property is actually the URL that this fetch will make a request to whenever we call the load more function, which I'll show you in a second. So what we need to do is we need to set cursor equal to a URL that has the next page that we would like to request. So it's going to look just like this, but we need to change that page property here. And if we take a look at the API response, it actually responds with which page of results this is. So in my specific use case, I can actually use that data that we get back from the API to determine what the next page is going to be. So right here, I can say the page is json.page +1. So essentially, whenever we call load more, we're going to make the request to this next page of results. So with that set up, we can try it out. So inside of our use effect here, we can say if the loading element is in view, then we can say list.loadMore. So loadMore is a function that they make available to us that will load the next page of results using that specific cursor. They also have another built-in method called reload if we, for whatever reason, need to basically reset the list. But for our use case, we just need the loadMore function. And you'll see my linter is yelling at me. It's saying, hey, you're using list in this use effect, so you need to add it to the dependency array. There's one issue with that, which I'll show you in a second. But let's actually see this happen. So I'm going to log right here, loading more. And I'll include the current time so we can see when exactly it got called. Let's head back to the top of the page and refresh completely. You can see that it actually makes the call to load more when the page initially loads, and we don't want that. So I'm actually just going to make a check to see, are there any elements in the list? And if not, there's no reason to call load more. And essentially, if the list is empty, that kind of means that the page has just loaded. So here we'll do if list.items.length has a value and it's in view. So now it's not going to call this when we first load the page because items will be an empty array, and then it's going to make the request for that first page of results, and then it's actually going to show that first page of images there. So let's see what this does for us. Let's do a refresh. You can see that it's still getting called twice whenever the page initially loads. Now, one more check we can do is to see if the list itself is loading. So if list.isLoading, this is a property that they make available to us. If this is not true, then we should call load more. And at this point, we're really close. At this point, it's still calling load more, even though we're telling it to wait until those images have loaded. And let's actually see what happens when I get to the bottom of the page. So we see that it's calling the API. It gets back the response, but then it called load more one more time. Now, ultimately, this has to do with our dependency array here. The list variable that we're getting back from useAsyncList is changing constantly. It's changing when isLoading is changing. It's changing when the items change. Basically, this changes a lot depending on the underlying state. And ultimately, we don't want this use effect to get recreated every time the list changes. We only want this to get recreated or rerun if in view changes. Now, there are a couple of other things that we could try to get this working. We could try use layout effect, which shouldn't actually run until the page itself has been updated. And so we're essentially trying to avoid a race condition where we're not loading and the images have already been added to the page. Then we can check for in view. And so to get around all of that, I don't want this to rerun whenever list changes. But if I remove it, the list variable won't always be the latest value. So we're going to wrap it in a ref. So let's actually create a variable called listRef. We're going to pull in useRef from React and then give it an initial value of the list itself. And now we actually want to update this ref anytime the list itself changes. So I'll create a use effect here that is dependent on the list. And a ref has a current value that you can actually write directly to. So I can say listRef.current equals list. I don't have to call like a setter method. Basically, this setting right here doesn't trigger a re-render, which is what I want. I want to have access to the latest list without triggering a re-render. Now that I've wrapped this in a ref, I can actually use the ref inside of here instead. So instead of saying list, I'll say listRef.current. So this is always going to grab the latest value. And if you don't believe me, let's actually just set a log right here. We'll say setting current. And because this use effect is defined above this one, this use effect is always going to have access to the latest one, but it's not going to get recreated if the list itself changes. Let's refresh. You can see on the initial page load here, it doesn't call loading, but if I make it down to the end of the page, then you can see it calls loading more, and it doesn't call it multiple times. And so if I get down here, you can always see right before the call to loading more, we're always setting that latest value. So even though this use effect isn't dependent on the real list, it's still getting access to the real one because we're using that current value of the ref. But at this point, we pretty much have infinite scroll. It's pretty good. It's pretty good. But one thing we might want to do is instead of waiting until we get all the way to the bottom of the page to trigger the call for the next page of results, we can actually set a rootMargin on the intersection observer, which will make it so that when we're a given distance from that specific element, it'll trigger the intersection. So potentially we want it to be when the cursor is like right about here, that's when we actually make the request for the next set of images. So I'm going to go ahead and remove all of these logs. And right here, when we use the useInView function, we can pass in a rootMargin. And I'm just going to set this to 1000 pixels. So whenever that loading element is 1000 pixels from being visible, then it'll actually trigger InView to be true, and that will fire off another call to our API. So now if we refresh one more time, let's actually just keep the network tab open so we can see the API requests. You'll see that before I even reach the end, it actually makes the API request. And so this gives you that true infinite scroll feel where the user doesn't even see the loading image. They literally just get to keep scrolling forever, but behind the scenes, we're actually making those requests for those next pages of results. So that's it for this infinite scroll example. If you want to take a look at the code, follow the link down in the description. And ultimately, I just really wanted to show how we could combine these two libraries, React Stately and React Intersection Observer, to have a really easy infinite scroll and probably less than 20 lines of code. I've seen a lot of other solutions out there that aren't as streamlined. It requires a lot more code, and this is definitely the simplest infinite scroll that I've seen. Now, As you notice, this was with just React running on the client. Implementing infinite scroll inside of Next.js introduces a lot of other challenges. So if you want to see me implement this same example, but with Next.js, definitely leave a comment down below. All right, I'll see you in the next one.